Alright, I'm a bit late today. Um, so welcome back to day 18. Also, I've realized that I think as you get enough stars, the these change color. So I think it all stays gray if you don't have many stars. And the more stars you get, the more color appears so that the image emerges. Is that how it works? Something like that. It's actually dependent on how many stars you get, whether you actually get the image or not. Um, all right, so let's begin then. So where were we? We were dodging Tetris pieces in a cave. Now what? You and the elephants finally reach fresh air. You've emerged near the base of a large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and toward the ocean. Bits of lava are still being ejected towards you, so you're sheltering in the cavern exit a little longer. Outside the cave, you can see the lava landing in a pond and hear it loudly hissing as it solidifies. Depending on the specific compounds in the lava and speed at which it cools, it might be forming obsidian. Oh, we can go to the nether. The cooling rate should be based on the surface area of the lava droplets. So you take a quick scan of a droplet as it flies past you. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result it approximates the shape of the lava droplet with 1x1 cubes on a 3D grid, each given as its X, Y, Z position. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were only two adjacent cubes, like 1, 1, 1 and 2, 1, 1, each cube would have a single side covered and 5 sides exposed. That's pretty straightforward, isn't it? Just count how many cubes you have, multiply by 6, and that gives you the number of sides. And then you subtract 2 for every pair that are adjacent. Alright, this one's easy. This is part 1. But it's an easier part 1 than some other ones. Okay. Let me readjust this. Get comfortable. Okay, so got to create a new file. 18, 16 is still not done. I don't know, probably today I'll have more time, depending on how long it takes me to do 18. Alright, so we've got, so what do we want? We just want to count cubes, right? So let's have a set of cubes. For line in F dot. Line in F dot read lines. X, Y, Z equals int by comma. Cubes dot add x, y, z. All right, so that'll give us all the cubes. Let's say neighbor pairs equals 0. So we want to count how many neighbor pairs we see. So looking at the cube we're currently on, we can check its neighbors. And if one of those is already in cubes, then we increment neighbor pairs, right? So we want for dx in -1, 1, wait, what's the easiest way to do this? Just write out the all the deltas explicitly. So it's like -1, 0, 0, 1, 0, 0, 0, -1, 0, 0, 1, 0, 0, 0, -1, 0, 0, 1. So for delta in that neighbor equals x plus delta 0, y plus delta 1, z plus delta 2. So that's the neighbor. If neighbor in cubes, neighbor pairs plus equal 1. So we'll only do this once because that cube already had to be in storage. We've got the new cube, so we only count the pair once. We don't count it twice because of the order in which we do this. So now print so it'll be 6 times length of cubes minus 2 times neighbor pairs. $3,650. Is that the calculation we want? Wait. Yeah. Okay. I did that pretty quickly. It's just, if only I started on time, I could have got a good rank. But other people would have solved that way quicker. That's like practically a one-liner if you use some clever Python things. All right, we've got part 2. Something seems off about your calculation. The cooling rate depends on exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sides that could be reached by the water and steam as the lava droplet tumbles into the pond. Huh? The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. What? I don't understand that at all. Are they saying if something's fully trapped on all sides, we subtract that one? Wait, no, that's not what they're saying. I don't understand. I don't think this was worded great. What? Let's read this again. So the scanned lava droplet is a bunch of cubes. Okay, fine. Surface area of air pockets trapped in the lava droplet. Oh, so if you use cubes to enclose air, then the surface area of all those cubes. Ooh. So we're trying to find hello, Quantum. Yes, this is a sort of breadth first search type thing, blood fill type thing, where you want to simulate steam and see how far it can reach. Hello, DJ. I've done part 1 pretty quickly. It was just take a bunch of cubes and calculate their surface area. But if 2 cubes are touching, then you don't count the area that's joined between them. So that's pretty straightforward. You just count the number of sides and subtract the ones which are touching. Now seems, if I understand this correctly, we want to imagine that we've got a bunch of cubes in 3D space and we have steam coming from a long way away. The steam will go everywhere. So we want to count how much of the surface of the cubes is hit by the steam. The idea being if the cubes enclose an area of air, then the steam will never reach that inner area. So it's kind of like a search kind of. I think we can just try to be smart with part 2 and it bit me. Okay. Well, we'll see. I might fall into the same trap. Alright, my initial idea is just to first create a bounding box around all these cubes, just so that we're staying within one place. and simulate steam appearing from like zero, like in one of the corners, and doing a flood fill breadth first search to all the spaces it can reach. And it can't go diagonally, but it can go in any of the 6 directions, okay? And when we've done that, and we've kind of reached all the cells we can with the steam, we then just, for every cube, see how many of its sides are touching this steam. I don't see anything wrong with that so far. So unless the input sizes are crazy, but they're not. They're all like under 20. So I don't see anything difficult here. All right, let's try that. So first of all, let's come up with a bounding box. It looks like everything is from 0 to 20. Let's just check to make sure. So let's say min value equals, I don't know, 0, max value equals 20, I'm guessing. Well, okay, let's just set it to 10. And then for each of those, for k in x, y, z, min v equals min of min v k, max v equals max of max v k, and print min v max v. So let's figure out what this box looks like. 0 to 19. All right, well, let's do, actually I should have set that to say 1, just to see it does actually attain 0. Okay, so we should start from -1 to 20. So lower, okay. The bounding box goes from -1 to 20. Okay, so lower bound equals min v -1. We might as well make this completely automated, so just so that it will work on any input. So max v plus 1. Okay, so we want to implement BFS, breadth first search. I could just copy it from when I did it in one of the previous problems. Sure, why not? When was that? Okay, a lot of problems here. Well, maybe it's actually quicker to check the browser. Alright, so it was something to do with... Oh, it was... Okay, I know. It was about somewhere between 10 to 15. It was the mountain climbing, hill climbing. In the middle... Hill climbing, here we are. So that's 12, right. BFS, so let's just copy this and manipulate it. Doesn't matter whether you use DFS or BFS. Yeah, but I always use BFS. I very rarely come across any situation where I want to use DFS. I just like BFS better. Conceptually, it makes more sense to me. DFS, I guess, has the advantage of lower stack size. Well, lower memory used at each step, but stack size could overflow, so that actually is an issue. You have to keep an eye on the stack. But DFS is, yeah, I agree. DFS is simpler to implement. I think the main reason I like BFS is because there are a lot of puzzles. For example, the one that we did earlier where it will actually give you the optimal result. In this case, it doesn't matter, but I think good to get into the habit of using it, especially if I want to extend to Dijkstra or A-star algorithm afterwards. Import Q. I mean, they're not really that different, are they? Literally, all that changes is you put it into a stack instead of a queue. Hello, Ku. How go the boulders? Have you done this problem? I just started, but I did part 1. That was surprisingly easy compared to the recent problems. Part 2, I don't see any problem with. It seems actually on the easy side, but we'll see once I program it. So I want to implement BFS from a start point. Q equals Q dot put start. We don't need it. G dot dist. Actually, I will actually do DFS. Might as well, just for the fun of it. Because, okay, I'll just do that. U dot append start. Post set equals set. So while Q current equals Q dot pop. And we just do this until we've actually exhausted the queue, so we don't need this check. We do need this neighbor method. In fact, it'll be good to wrap this up as I'm get neighbors. Get goobers. Get neighbors of position. For delta n that neighbor equals we need to check if it's out of bounds. Okay, in neighbor, if not lower bound less than or equal to k is less than or equal to upper bound. Continue. Neighbors dot append neighbor, neighbors. Alright, so we want neighbor and get neighbors. Current. If we've seen it before, skip it. Otherwise, q dot and neighbor at closed set dot add neighbor. That's it, isn't it? Well, I'm gonna name it DFS. Yeah, it is easier, isn't it? Then we want to return closed set because we've got the spanning set. We can actually just do this. All right, so we want to just find the spanning set of. Just want to start from. So let's say, what is it? It's Steam. Okay, Steam cells equals DFS of. Let's say lower bound, lower bound. Lower bound. So we start from a corner. Let's just check that runs. Okay. Is it not terminating? I mean, that it absolutely should terminate quickly. It's 20 by 20 by 20. Oh, I didn't add. Would that be the problem? To start? Well, no, that shouldn't be a problem. It just means start will get added later. It's an infinite loop. While queue, so while it has stuff, we get something out. Or neighbor in get neighbors, current. Oh, let's print some stuff. Okay. Yeah, it's growing like crazy. What is going on here? The most that we could ever have here should be. How does the not operator work with double inequalities? I think the inequality takes precedence. I can double check that. Well, that doesn't prove anything. This is a different issue, but yeah, I think the inequality takes precedence. So I think I've done that before with that issue. So closed set dot add neighbor. So once an item gets added to closed set, it's a set. Wait. What? Print length of closed set. If this grows, that means we're going outside the bounding box. Yeah, no. Yeah, we're going outside the bounding box. Whoops. Oh, the continue is wrong. Hang on. Continue just goes to the next K, so this whole thing is meaningless. It should be this. Well, continue or break, it doesn't matter, but we say else do this. Yeah, actually, or I could do it like this. That's actually just simpler. If no. No, that's wrong. We don't want to take that not out because we need it to be within the bounds for all K. So we need to say this. If we get through this for loop without breaking out, only then do we append the neighbor. There we go. It looks like it's all within 20 also. Alright, so so these are the steam cells. What's the last thing we need to do? Alright, we'll just print the length. Steam cells. Now we just need to go through all the cubes. For cube in Jealous of Python, sets of tuples are just so nice for these problems. Yeah, definitely. I think Python users have, some of these problems have been really nasty to non-Python programmers. Like the one about orderings of nested lists. My god, I can't even imagine trying to do that in C++ or whatever. JavaScript users also had a good time because they could use JSON to load that. But Python, despite I think the easiest, you can use eval or JSON to load all the nested lists into memory, and then you don't have to write your custom parser. But yeah, I know JavaScript has also seen some good problems as well. So Python and JavaScript is the way to go for these problems. Oh, is there an eval in JavaScript too? Yeah. Alright, so for cubing cubes, for neighbor in get neighbor's cube, if neighbor in steam cells, we're counting the surfaces which are touching the steam. I have to double check this. One, 2, 1, 5, 0. Let me, before I submit this, let me... They don't explicitly say, but they're saying exterior surface area, so disregarding those which are touching air only. Okay. Yeah, I think this is right then. Nope, it's too high. Wait, what did I print exactly? The last thing I printed was the result. Yeah, what the heck? That is too high. Whoa. What's that's not even within. It has to be less than the first answer we gave. Oh, I forgot to remove the neighbors. So basically, I'm not removing the neighbors in the same way that we did the first part. Whoops. Okay, so yeah, and it's really great being able to throw tuples in with mixed contents as well, especially when you're doing pathfinding like Dijkstra and stuff. You can throw strings and stuff into the tuples as well. Alright, so we need... If neighbor in Steam cells... Oh, wait. Okay, two things are wrong here. No, one thing is wrong here, essentially. This is just expanding. This Steam flood fill wasn't even looking for the cubes. It was just filling the bounding box with steam. We've literally just got a 20 by 20 by 20 grid of steam. Forgot to check. If neighbor in cubes continue, that's it. We skip it if it's a cube. Yes. There we go, 2118. That's lower than 3650. That makes sense. I want to see what this looks like now. I know in the subreddit, every time there's a problem, after the problem's been solved, lots of people post visualizations, which are really cool. Sometimes they do it in Minecraft, like the falling sands thing. Someone actually built it in Minecraft, which was incredible. Or sometimes they just do it in in some really obscure game or visualization tool. All right. 2118. The pathfinding in the mountains was also pretty popular with Minecraft visualizations. Yeah. There we go. This was an easy day. A nice light, easy day after the last couple of days, which were quite difficult. And I still haven't done problem 16, so I will do... I mean, because I finished this one quickly, I will do that at some point today, but not yet, because I need to go to the supermarket, but I do have time. So basically I've solved everything except for 16 part 2. Yeah, I saw someone had even made a mod for Minecraft where they were trying to mod a zombie to chase a villager who was standing on top of the mountain. But I don't think you could get it working because it's kind of built in that the zombies can't even see that far anyway. Bloodfill paint the surfaces. Yeah, I was thinking about whether I should be going along surfaces. It would work. No. Well, it would work, but you'd have to have multiple starts. You'd have to start at every cube that hasn't been covered yet. And you'd have to find the... Yeah, no, yeah, it's not quite... I mean, you can make it work, you just have to use the cubes which are on the outside. So you have to drop a line from the bounding box, array, see where it hits, and that's your starting point, and you have to do that for every cube essentially. So no, even that doesn't work. Yeah, I don't think you can make that work. Yeah, yeah, exactly. Because you can ruin it just by having a small hole somewhere. So you actually need to um be searching through the volume, not the cubes. Yeah, it was an interesting problem. There was nothing really difficult there, apart from the different directions someone might go with the flood fill. It was a pretty. I mean, it's DFS and it's pretty straightforward. And they gave us really generous numbers. Look at that. It's all with 0 to 20. They could have gone higher. They could have gone to 100. I think it would still work. Be like 1 million cells. All right, let me have a look at stuff. Oh, someone else has joined my leaderboard. Samuel de Gueldre, was he? No, I don't think he appeared in chat. Maybe he saw me on YouTube. Oh, that's you. Wait, which one? Samuel or Araronia? So you joined recently then? Because okay, that's cool. Alright, well, yeah, I've got time today to actually do 16. I think I'll be able to finish it. I just kind of... Wait, so did you find me on Twitch or YouTube? Of interest. Twitch, okay. I think a few problems ago I had Eric himself visit as a viewer. I can't remember which problem it was. I think it was the sand problem, the sand dropping problem. He showed up at the end. The guy who made this site. What was I looking for here? My rank. Oh, but I started late, so it's not going to be that good. I always get lost here. Yeah, if I had started on time, probably I would have had an okay rank because I did it reasonably fast, but it was an easy problem. So like the competitive coders, they would have done this in seconds. How can we actually find those times? 18. 4 minutes 24. The top 100, 2 minutes 55. The top 100 people did both problems, both parts in 3 minutes. Oh no, this is first star. Okay, 12 minutes 29. That's actually 12 minutes. That's actually higher than I thought it might be. I think I could have beat that if I'd started on time and not streamed it, so I wasn't talking to anyone. I think I could have beat 12 minutes. But I'm not doing it that way. I'm doing it the Twitch way so I can explain what I'm doing. Saroxas. Out of interest, how did you find this channel then, if you don't know what you're watching? But to explain things, this is Advent of Code. It's every day a problem is released until the 25th. And it's a coding problem, and it's usually of the nature that it's like a little bit mathematical or a little bit a problem that utilizes the knowledge and skills that you would need as a programmer. But oh wow, you found me through Discord. Okay. It's always a little bit on the mathematical side, so it's less about strictly software programming stuff and more about solving mathematical problems. Yeah, I mean, this one was involving cubes and counting the number of surfaces which are exposed to a gas. You get all sorts. You get climbing a mountain, like using a pathfinding algorithm to find the shortest path to the top of the mountain. You've got this monkey thing, which was like a sort of like game theory kind of thing. Yeah. I don't know if you code yourself, but it's good. And every year they do it, and there's loads of past years to catch up on as well. And it's accessible to non-coders, I would say. The first few problems, at least. It gets harder, but the first few problems are like find the max of a set or something, which is actually pretty kind of like first exercises you would actually do in a programming course. So they do get hard. Like it's the turning point was around 15 to 16, where you actually need. This cube one was fine. The previous few, you actually needed a bit of knowledge. There was one where you needed at least a little bit of number theory / abstract algebra knowledge. A very small amount, but just to understand how prime numbers work and how prime number fields work. But took me like 12 hours of active time for day 16. Oh, this is the one I haven't finished. Yeah, okay, I guess I'll have to do that today. But I have an idea for how I'm gonna round it off, so hopefully I'll finish it within an hour, but we'll see if my idea actually works. Yeah, I would say so. In streaming all these, I think I've managed to do them within all of them within 1.5 hours or so. If I wasn't streaming, if I was just doing it quietly on my own, I think I probably could have halved that. Probably, so I would say about 40 minutes would be about right. Okay, well, that's all. I need to upload this video to YouTube, and then in a few hours' time I might be back, so maybe I'll see you then. Otherwise, there's the other thing I need to do, which is coding game, which is a whole different tournament. I guess Ku must be waiting for me to get back to that as well. If this gets you to start coding, I'd say that's exactly what the advent calendar wanted to achieve. Yeah, absolutely. That is Eric's goal. And it's popular. There's like hundreds of thousands of people on this leaderboard now. I can't remember how to find the list, but yeah, here we go. 200,000 people did the first problem. Probably more than that attempted it, but didn't complete it. So yeah, it's reaching the millions. All right. Thanks for watching. I'll see you for the next problem.